Sawubona, this is Liam in for Bear. Here's the whole chapter in one experiment. Take one CSV, a real validation result, byte for byte fixed, and hand it to two people. Tell the first to reassure a nervous partner. Tell the second to get that partner asking the right questions. Same data comes back as two dashboards. The partner leaves the first one reassured and the second one with questions. The questions were the appropriate reaction. So the numbers were identical, both charts were accurate, and only one of them was honest. How? Act 1, one dataset drawn two ways, and the two readers walk away believing different things about whether the system is safe. Watch it happen. The misleading build opens with one bold number, 94%, and squeezes the subgroup gap onto a truncated axis until the disparity vanishes, calibration hidden in a tab called Advanced Metrics. The honest build shows those same subgroups on one shared baseline, the disparity visible at first read, the calibration warning in the open, not one digit changed between them. And this is the part you have to feel in your bones. The partner is non-technical, time-pressured, deciding from what they understood. Off the first dashboard they proceed, reassured. Off the second they pause and ask. Same evidence, two beliefs about whether to ship, and the structure of the chart, not the data, decided which. Act 2, why this is even possible. A 50-year-old idea about media, pointed straight at your dashboard. McLuhan said the form of a message shapes its meaning before any content arrives. A dashboard is a medium. Engineers are the worst offenders here, not from malice. They treat a chart as a transparent pane of glass through which the data is simply seen. It isn't, it's a lens ground to a prescription. And if you don't choose the prescription, you inherited your plotting library's default, tuned to look finished, not to be honest. Structure argues on its own. Open with one bold headline metric and the form says, this number is the answer, scan it, decide, you may never reach the detail. Open with a panel of equally weighted views and the form says, no single number suffices, integrate, slow down, different arguments, identical data. The argument is made before the first number is read. Act 3, if structure argues, then honesty needs a grammar. Two rules do most of the work, and both are older than your plotting library. Rule 1, a chart is not a way to display data. It's a way to answer one question with data. Can't state the question in a sentence. You don't yet know which chart to draw. The Financial Times sorts every chart type into 9 question families: deviation, correlation, ranking, distribution, change over time, part to whole, magnitude, spatial, flow. State the question, find the family, pick the chart. Start from the data shape instead. And you reach for whatever default the spreadsheet offers. Rule 2, once you know the question, choose the visual channel that encodes the answer, and that's not taste, it's measured. Cleveland and McGill rank the channels. Position on a common scale is read most accurately. Length next, then angle, then area, then volume, each read worse than the last. Color is weakest of all for quantity, and excellent only for category. Here's why the ranking bites. Take one number and double it. As length 2 bars, the reader sees double correctly. As area 2 bubbles, double the value quadruples the ink and the eye reads far more than double. Same quantity, honest as a bar, inflated as a circle. Reach for area only when precision doesn't matter. Reach for volume never. Act 4, once you can see the choices named, you can't unsee them. The catalog and the property that makes every item on it dangerous. 9 recurring moves, truncated axes, inconsistent axes across panels, aggregation that hides a distribution, color asymmetry, cherry-picked time windows, scale trickery, chart junk in 3D, missing baselines, labels that prejudge, and the most dishonest of the set, selective uncertainty, showing confidence intervals where they help your case and dropping them where they'd hurt it. Take the most common one, 2 model versions, 92 and 94%. Start the y-axis at 0 and the bars are nearly the same height, a small real difference. Now start it at 91 and version B towers over A, 2-point gap rendered as a landslide. The data never moved, only the axis floor did. And here's the trap. The truncated chart is legitimate when 0 isn't meaningful. Stock price is live on truncated axes for good reason. The chart looks identical either way. The choice is the difference. That's the thread through the whole catalog. Every move has an honest use, which is exactly why it's dangerous. The pixels are identical whether the choice was honest or not. Truncate because the range genuinely is narrow, or truncate to amplify, same chart. Gray a subgroup because it's context, or to pull the eye away, same chart. Nothing in the image tells you which. Only the choice does, and the choice is invisible. Act 5, the rules are best learned from failures. 4 charts, 3 that misled, 1 that has stood as evidence for 170 years. The night before the Challenger launched in 1986, engineers had 13 charts on the table. The evidence was in there, O-ring erosion was worse in the cold, but no single chart drew the temperature to failure relationship for a decision maker under pressure. The chart that would have made the danger legible was never drawn. Management read the ambiguity as safe. 7 astronauts died. Now watch a chart reverse its own data. A Florida-lined chart of firearm murders marked the year a stand-your-ground law passed and appeared to show killings dropping right after. But the y-axis was inverted, 0 sat at the top, high values at the bottom. The post-law spike, deaths climbing 521, 740, 825, rendered visually as a fall. Every number was correct. The reader took away the exact opposite of the data. Sometimes the right chart is no chart. Picture a pole where two options sit a hair apart and the margin of error is larger than the gap between them. That's not a lead, it's a tie. Draw it as two bars, one slightly taller, and you've encoded a difference that isn't in the data, a lie of composition. The honest move is to make the confidence interval visually bigger than the effect, or to write one sentence, it's a tie. 1854, London. A cholera outbreak, and John Snow maps every death to its street address. A dark cluster tightens around one spot in Soho. Push in, and the center of the cluster is a single water pump on Broad Street. That alone is a hypothesis. What makes it evidence is the next move. Snow drew every other pump too. The deaths did not cluster around those. By showing what would have to be true for him to be wrong and letting the reader rule it out inside the frame, the map became evidence instead of illustration. That is the standard. Show all the pumps, not just the one you're pointing at. Act 6. Every honest chart has to show its doubt, and doubt comes in two kinds that need two different tools. First face aleatoric, the irreducible spread of the data. Error bars and confidence intervals are built for it, and it's what most guides mean by show your uncertainty. Second face, the one guides go quiet on, epistemic, the gap between what you know and what's true. It's reducible in principle, better data would close it, and most charts hide it entirely. A chart of kidnapping rates built from news mentions has epistemic doubt that swamps the data. Different faces. Different tools. The cautionary case, a map of kidnapping rates across Nigeria that was actually a map of news stories about kidnappings. The database counted media mentions, not events. The spikes tracked coverage, not crime, and nothing in the chart disclosed the proxy. It carried the full visual authority of ground truth. As one journalist told the map makers, validate your own data. It isn't true just because it's on a map. For the aleatoric face, the strongest tool most guides skip, the quantile dot plot, say a 1 in 5 chance of failure. Written as 20%, it makes the reader do arithmetic under pressure, and even physicians get it wrong. Drawn as 20 dots with 4 filled, the risk lands position, the best perceptual channel, meets natural frequencies, the way people actually reason about chance. 4 out of 20 beats 20% every time. And whatever tool you pick, one rule governs the layout: make the uncertainty visually equal in weight to the estimate. A small error bar on a big bold number says this is the answer with a quibble. When the margin is large relative to the effect, the range has to be as prominent as the point, because then the uncertainty isn't a footnote, it's part of the finding. While you're at it, round off the false precision. 0.847291 with a plus or minus of 0.05 is not a 6-decimal number. It's a 0.85 number. Act 7 and the honest one. The trade-off underneath the whole field and the form that refuses to pretend it's finished. Here's the trade you're actually being offered. A misleading chart is faster to build than an honest one and more persuasive on first contact. The misleading dashboard from the opening wasn't harder to make, it was a handful of choices away. Truncate here, gray there, bury the calibration curve, 30 seconds each. What you spend is the reader's ability to reach a different conclusion than the one you wanted. It has been done well for a long time. At the 1900 Paris Exposition, W.E.B. Du Bois built some of the most original data visualizations in history, hand-drawn spirals and bars where every design choice was deliberate and the politics of each choice stayed fully visible. Not neutral, not pretending to be. Honest precisely because the argument was owned out loud on the page. One last form, validation analyzes are usually shown as if finished, polished, single version, authoritative. That finishes itself an argument, the analysis is complete, this is the answer. Usually it isn't. The living deck refuses the pretense, every version dated, a changelog documenting what changed and why, superseded slides kept in a previously section. It's structural argument by form, this is provisional, this is the latest state. And the changes are part of the work. Let's recap with Claude, the verdict on visualization. A chart is not a transparent transmission of facts, it's an argument made through structural choices, and the argument lands before the first number is read. Every misleading move has an honest twin, and the pixels never tell you which one you're looking at, only the choice does, and the choice is invisible. Honesty has a grammar, the question first, then the perception hierarchy. Then uncertainty given equal weight and its source disclosed inside the frame. The misleading chart is always faster and more persuasive, which is exactly why the audit is the work. A dashboard that visualizes findings unfaithfully isn't a communication failure downstream of good analysis, it's a validation failure at the output layer. The design choices are validation choices, there's no neutral. Your turn, here's the prompt pasted into Claude. It reads, I have a validation finding I need to chart. Help me build two dashboards from the exact same data, one honest, one deliberately misleading. First, before we draw anything, make me lock a prediction which design choices will do the misleading work and which one will be hardest because the data refuses to be obscured. End quote. That's the whole chapter compressed. The point isn't the misleading version. It's easy, that's the lesson. The point is the prediction you lock before you build, and the discomfort when you recognize your own past dashboards in the misleading one. After you've done this once, you don't see charts the same way. You see the choices. Run it on a finding you actually have to ship. The chart isn't neutral, it's arguing. Visualization from computational skepticism for AI. Lay 'em in for bear.